Welcome to Spring LIB.
So in the first part of this problem, we have a compound LiCOO2, and we have to find out the oxidation number of cobalt here. So as we know that the total sum of the oxidation number of all the atoms or ion present in a compound add up to the total charge or net charge on that compound. So if we just add up the oxidation number of each atom or ion present here, so for lithium, as it is a group 1 element, it will have an oxidation state of +1, and since there is only one lithium, we can just leave it like this. And then for cobalt, if we let the oxidation number of cobalt as X, so plus X plus for oxygen uh, most commonly has an oxidation state of -2, except when it is in the hydrogen peroxide H2O2 or with fluorine. Other than those exceptions, oxygen always have -2, and we have 2 oxygen here. That means we have to multiply it by 2, and this will be equal to the net charge on the compound. And for neutral molecule, it is always 0. That means it will be equal to 0. Now if we just okay, so here we have -4, and if we just rearrange it, we will have X equal to +3. So +3 is the oxidation state of cobalt in this compound. Now if we go for the second one, where we have NaLH4, and here we have to find out the oxidation number of aluminium. So again, sodium is a group 1 element which will always have a +1 oxidation state. Then for aluminium, we let it as X. And for hydrogen here, so hydrogen usually has an oxidation state of +1, except when it is bound to a metal or with boron. So as it is bound here with sodium, that means the oxidation state of hydrogen here will be -1. So -1 for hydrogen with all metals and with boron. So here we have a hydrogen oxidation state as -1, and we have 4 hydrogen. That means we time it by 4 will be equal to 0. So here we have +1 plus X -4 equal to 0. And ultimately we have X is equal to +3. So this is the oxidation state of aluminium here in this compound. Now if we go to the third one, in the third compound we have CH3OH. So CH3OH is an organic compound which is an alcohol. So for this organic compounds or hydrocarbons, there is a different rule for counting the oxidation state or number. So you have to find the oxidation number of carbon here. So what we do, we have to first draw the structural formula of the hydrocarbon. So there will be 4 hand of carbon, and here 3 hydrogen will occupy 3 of them. One side we'll have OH. So the rule for counting the central carbon atom or the alpha carbon atom, so here we have only one carbon, but when we have 2 carbons, then we basically have to find out the oxidation number of the alpha carbon, and alpha carbon is the carbon which is attached to the functional group of the compound, and here the functional group is OH. So this carbon is alpha carbon, and here we have only one carbon, so we don't have to worry about that. But the rule here is, for the alpha carbons, the oxidation number of alpha carbon is the number of bonds with heteroatoms, which is basically oxygen, nitrogen, phosphorus, chlorine, or any other non-metal other than hydrogen. So we have to count number of those bonds, and we have to subtract number of bonds with hydrogen from that number. So here we have only one bond with the heteroatom, which is oxygen here. So we have one minus we will have to subtract the number of bonds with hydrogen. So here we have 3 bonds with hydrogen, so you have to subtract 1 minus 3, and that will give us minus 2, and this is the oxidation number of the carbon here. So again, for the hydrocarbons, to find out the oxidation number of the alpha carbon, we have to find out the number of bonds with heteroatoms. That means bonds with oxygen, nitrogen, phosphorus, chlorine, or any other atom other than hydrogen and carbon. And then we have to subtract the number of bonds with hydrogen, and that will give us the oxidation number of the central carbon or the alpha carbon. Now, and then we have GAN. So in GAN, so gallium is a group 3 element. That means it will have oxidation number of +3. And we have, for nitrogen, if we consider it X, we have to find the oxidation number of nitrogen here, and the net charge here is 0 as it is a neutral molecule. That means X is equal to -3. So the oxidation number of nitrogen here is -3 in this compound. Then we have HClO2, and we have to find the oxidation number of chlorine here. So as usual, hydrogen has an usual oxidation number of +1, and we have only one hydrogen. Then we add the chlorine's one as X, and for oxygen it is -2. We have 2 oxygen, that means times 2 equal to the net charge 0. And then we have X +1 minus 4, that means -3 is equal to 0. It will give us X equal to +3. So in this compound, the oxidation state of chlorine is +3. So if you notice that normally or usually the chlorines or halides have an oxidation state of -1, but when it is bound to oxygen or fluorine, in those cases, the chlorine, bromine, iodine, these halogens will have an exception to this rule, and they will have a different oxidation number, as we have here +3 for this compound. Okay, and the last one we have BaCrO4, and we have to find the oxidation number of chromium here. So again, barium being group 2 element, it will have +2. Chromium, for chromium we'll get X. For oxygen it is -2 times 4 and equal to the net charge 0. Then we have X +2 minus 8, that means -6 is equal to 0. It will give us X equal to +6. So this is the oxidation number of chromium in this compound here.